Hello everyone, welcome to Simplify Your Concept. So this is the second part of the Kirchhoff's laws series where we will be dealing with the problem solving. So let's start with the first problem. So the first problem says that we need to find out the value of currents in all the branches in the circuit shown below. So this is the circuit which is shown here. We need to find out the branch currents. Now what are the branches? This particular is a branch, this is a branch, this is a branch, this, and this. These are the branches. So we need to find out the current in all these branches, okay? And if you see here, there are some currents which are entering these nodes and some are leaving these nodes, right? And the values of the resistance of each branch are also mentioned here. Before we go to the solution, I have just noted down some simple steps which can be followed to get the solution in a very easy way. So let's see what are those. So the first step is that we need to assume the direction of the current in the loop. Now if you look at this particular circuit, we have only a single loop. So basically we are going to assume the direction of the current in this particular loop. Second step is to find the value of currents in all the branches in terms of an unknown current. So since we do not know the value of the currents here, we are considering this loop which is a single loop. So we will be considering a single current in one of the branches, and with that unknown current we will find out the current in all the other branches using KCL. The third step is to find the voltage in all the branches since we know the resistance, and we will be able to find out the currents also. So we will find out the voltages by applying Ohm's law. And finally we will be applying KVL in the loop to get the value of that unknown current. And now once we know the value of the unknown current, we will substitute that value in all the current equations to find out all the branch currents. So let's get started with the step number 1. So I will just write her down here, step 1, which is basically assuming the current direction. So I have drawn the circuit here once again. So just for simplicity, first let us mark these nodes with some names. Let's take this is A, this is B, this is C, D, E, and F. Okay, so I'm going to assume the direction of the current in the anti-clockwise here. So I can write down that the current which are flowing in the branches are moving in this anti-clockwise direction. So with this we complete the step number 1. Okay, now let's talk about step number 2, which is basically to find out this branch currents in terms of an unknown current. Okay, so finding with unknown current, I would say I. Okay, so now I'm just assuming the current which is flowing in IAB is I current. Okay, this is again an assumption. Now I will apply KVL at this particular node at B. Okay, so apply KCL, sorry, I will apply KCL at node B. So you know that what does KCL say is that the summation of the incoming currents should be equals to the summation of the outgoing currents, right? So what are the incoming currents at particular node B? So I is the incoming current, and then the outgoing currents are this 30 amperes, and we have one more current which is IBC. So the equation will be I is the incoming current, which will be the sum of outgoing current, so that is 30 plus IBC. So now therefore I can write it as IBC is equals to I minus 30. This is one of my branch current, I minus 30 here. Similarly, if I apply KCL at node C, again we are going to apply KCL. So sum of incoming currents, that is IBC, which is I minus 30, and incoming current 70 amperes will be added to it. That will be equals to this current which is ICD. 30 plus 70 is equals to ICD. So therefore I can write it as ICD is equals to I plus 40 amperes. So if you notice here, I am finding out all the currents in terms of a single unknown current which is I. Okay, so this is a very simple trick to remember. that whenever you see the number of loops, please consider that many number of currents. So since here we have only a single loop, I'm considering only one unknown current, and considering that unknown current, I will be finding all the other branch currents. Okay. Now let's talk about the other node. Apply KCL at node D. So here I'm talking about at node D. So I have the incoming current as I plus 40, and I have the outgoing currents are 120 and IDE. So I can write that as I plus 40 is equals to 120 plus IDE. So therefore IDE would be equals to I minus 80. Okay. And then we have the next node, that is E. So okay, I will also write down this value here. At E, if you talk about, we have incoming current as I minus 80, plus we have 60 amperes coming from external, and then this is equals to IEF. So IEF is equals to I minus 20. Okay. And finally, we have the last node. Apply KCL at node F. So at node F, we have the incoming current as I minus 20, and we have the outgoing currents at 60 plus IFA. So therefore, I can write IFA is equals to I minus 80. Okay. So now with this, we complete the step 2, where we are finding all the branch currents with an unknown current I. Okay. Now let's go and check what we have. Step number 3. Step number 3 says that find the voltage in all the branches by applying the Ohm's law. So I have one other circuit here which I will be using to find out the voltages. So now I'm talking about step number 3, where we'll be finding the voltage across the branches. Okay, so first let me consider, I will just write it down here. What is the voltages? VAB, VBC, VCD, VDE, VEF and VFA. Okay, so these are the voltages which we need to find out. So Ohm's law is nothing but what? I into R. Okay, so VAB is equals to 0.2, that's the value of this resistance, into what is the current we have here? I. Okay, so here what is the current we have? I minus 30. I'm just writing down the value of current so that it will be easy. I plus 40. Here we have I minus 80. Here we have I minus 20. Here again we have I minus 80. Okay, let me just check once again if I have not made any mistake. Yes. Okay, so coming back to VBC, it is 0.1 into I minus 30. VCD 0.1 into I plus 40. VDE is 0.3 into I minus 80. VEF is 0.1 into I minus 20, and VFA is 0.2 into I minus 80. Okay, so we have got the voltages in all the branches. With this, we also complete the step number 3. So now what is the step number 4 says? Step number 4 says we need to apply KVL in the loop to get the value of this unknown current. Okay, so now let's apply KVL in this loop. So now finally we have step number 4, where we are applying KVL in the loop. So now what does KVL says that? It says that the algebraic sum of all the voltages in a closed loop is equals to 0. So it's nothing but addition of all these voltages is equals to 0. Alright, so now let's apply it. So we have VAB plus VBC plus VCD plus VDE plus VEF plus VFA is equals to 0. Okay, now just I will substitute these values with their equivalent multiplication of resistance and current. So this will give me 0.2 into I plus 0.1 into I minus 30 plus 0.1 into I plus 40 plus 0.3 into I minus 80 plus 0.1 into I minus 20 and 0.2 into I minus 80 equals to 0. Alright, now if you look at this, we have a single equation and we have a single unknown, which is I. So by resolving this equation, we can get the value of I. So I'm just opening all the brackets and writing down. So 0.2 I plus 0.1 I minus, so 0.1 into 30 is 3 plus 0.1 I plus 0.1 into 40 is 4 plus 0.3 I minus 0.3 into 80 is 24 plus 0.1 I minus 2 plus 0.2 into I minus 16 is equals to 0. Okay, now add all the terms which have I in it. So 0.2i plus 0.1 plus 0.1 plus 0.3 plus 0.1 plus 0.2, which is equals to 1. So I can write it as I. Then I have this term, unknown terms, all the unknowns. So 3 minus 3 plus 4 is 1, minus 24 is minus 23, minus 2 is minus 25, and minus 16 is minus 39 is equals to 0. So hence I can say that I is equals to 39 amperes. Okay, so therefore we have got the value of the unknown current as 39 amperes. So with this we also complete this step number 4. And finally we have the step number 5, where we are going to find out all the branch currents by substituting the value of this I current. Okay, so what is IAB? This is nothing but I, which is 39 amperes. Now IBC is equals to I minus 30, which is equals to 39 minus 30, so it is 9 amperes. ICD is equals to I plus 40, so it is 39 plus 40, which is 79 amperes. IDE is I minus 80, so that is 39 minus 80, so it is minus 41 amperes. IEF is I minus 20, so that is 39 minus 20, which is 19 amperes. And finally we have IFA, which is I minus 80, that is again minus 41 amperes. Okay, so these are the branch currents. Now if you look at here, we have two branch currents which are negative in nature. What does it mean here? It says that these currents are actually flowing in the opposite direction based on the assumed current direction. Okay, so here I can say that the current flows from E to D. Okay, so you can also write that as IED is equals to 41 amperes. Alright, similarly here I can write that the current is IAF is equals to 41 amperes. Okay, so this is a very simple way. If you follow the following steps, it will be very easy to solve this type of question. So make sure that whenever you start any problem solving, please try to break it into simple steps so that it will be very easy to find a proper solution for it. So that's all for today. In the next video, we will solve some more problems. If you like it, please give a thumbs up and subscribe to the channel. Thank you for watching and see you in the next one.